Hi, welcome back students. In this video we are going to discuss about DFS and BFS. So first DFS means depth first search. So he has given a problem. So by using the problem we can simply prove the DFS. Use DFS to find in the spanning tree of. He has given a diagram. So we have to solve this problem by using DFS. So first of all we have to put some points in doing the problems on DFS. So some of the points are in depth we have to take consider the DFS. And the closed figure must become an open figure. So no closing thus must there, it must be an open figure. So like this, see here I have started from depth. First I have started from here and I am going from here to there. So here from there, here like this, and it must be not been closed. By considering only the depth side only I am taking. So now the figure becomes like this. I am not closing any end. See here I am not closing. So here I am not closing. Here I am not closing. So the solution of the DFS is like this. Here I have to put in mind that no closings must be there. That means no closed graph must be there. The graph must be opened. Here I have a formula also for DFS. So formula for removal of the edges is E minus V plus 1. So for the above problem I have edges are 11 and the vertices are edges are 11, vertices are 7, edges are 11, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 11 vertices. So they are 11 edges. Next vertices are 7 and plus 1, that equal to 5 edges. So I have to remove the 5 edges. So we have to put in a mind that we have to remove the 5 edges, but here we have to not close the diagram. That means we have to put the diagram in an open view, not in a closed view, and so that the removal will be like this. So here after removing this I have get a DFS for the following figure. So the formula for removal of the edges is E minus V plus 1. So here the number of edges are 11 and the vertices are 7 plus 1. Then the value becomes 5. So I have to remove 5 edges so that the closed diagram will become as open diagram. And the open diagram of DFS looks like this. And this is the solution of a DFS to the given problem. So use DFS to finding the spanning tree of. He has given another problem. So for this problem, he has given a 1, 2, 3, 4, 5, 6 edges. And what is 1, 2, 3, 4, 1, 2, 3, 4. 4 vertices are there. So here for this DFS, we have to go in depth wise and we have to make the closed diagram as an open diagram, and in the depth wise, so the solution becomes like this. So this is the solution of a DFS problem. So there is another solution also. This is also a solution of this problem. So here we have to take the closed diagram into open diagram by removing the edges. We have to close the diagram, and for removal of the edges we have a formula that the formula is for removal of the edges we have a formula that E minus V plus 1. E represents number of edges, V represents number of vertices plus 1. Here in this figure we are having 6 edges, 4 vertices. That means we have to remove 3 edges. So after removing 3 edges, our diagram will become, our graph will become like this. So this is the solution of a DFS, or this is also a solution of a DFS. So here we have to put in a mind that the closed graph must become a open graph and the removal of the edges must not change. So 3 edges should be removed so that the closed graph may become a open graph. So this is the problem on a DFS. See, use DFS of a spanning tree. Here he has given a one of a problem on DFS. So for this we have to see in depth wise and such that it must a closed diagram must become a open diagram. In the depth wise, from starting we have to go from a depth wise. So the solution for the DFS is this. So I have started from here and there is no closings here. Already it is opened, and I also know that the formula for removal of the edges also, the formula for removal of edges is E minus V plus 1. So in the figure I am having, in the graph I am having E number of edges is 12 and the vertices is 8 plus 1, that equal to 5. So 5 edges I have to remove. So I have removed the 5 edges so that the closed diagram will become an open diagram. So this is the solution of a given DFS problem. Now I will take BFS. BFS means breadth first search. So in the breadth wise, that means in the diagonal wise, in the adjacent wise, we have to see the diagrams. So here now I will start the problem from the BFS. So use BFS for the spanning tree. So the BFS for the spanning tree is like this. So here the closed figure, figure must become an open figure, but here there is starting from a breadth wise we have to start. So name itself it is having BFS means breadth first search. We have to search in a breadth wise. By this we can see that the graph will become closed graph will become a open graph. So the graph for the given BFS problem is looks like this. So the solution for the BFS is, we know that the removal of the edges formula is E minus V plus 1. That is number of edges is having 12 and the number of vertices is 8 plus 1, that equal to 5 edges. So I have to remove the 5 edges and I have removed the 5 edges. So this is the solution for the BFS for the given problem. Now I will take another problem. So use BFS to finding the spanning tree. BFS means I have to put in a mind that I have to see the diagram by breadth wise. But considering the breadth wise I have to see, but a closed figure must become a open figure. So the following figure will be becomes like this. The closed figure will become like an open figure. So the solution for the problem is BFS is this. So all the closed regions becomes a open region. So I have considered from taking from the breadth wise. So this is the solution of a BFS. Already I have know the formula for removal of edges. That is E minus V plus 1. That is 10 minus 7 plus 1. I have 4 edges that has to be removed. So I have removed the 4 edges. So this is the solution for the given problem. So use BFS to find the spanning tree of a given. So here also I will consider breadth wise only. So the answer for this is, by taking the breadth wise, I have taken the closed figure as an open figure. Now this figure is becomes like this. So we can simply draw the figure not like this also. We can draw the different ways so that we have to put in a mind that the closed figure must become a open figure and the number of removals must be correct. Here the number of removals are 3. So the number of removals must be 3 and we have to check it in a breadth wise. So not only this diagram, we can consider another many diagrams. We have to put in a mind that we have to see breadth wise and we have to see that every closed figure must become a open figure and the number of removal must be same. That is 3 edges must be removed. So whatever the graph we have to consider, so we have to follow this formula. So the formula for the removal of edges is E minus V plus 1. So this is about the BFS and DFS. So this is about the breadth first search and depth first search.